On February 17th, someone typed a single sentence into a GitHub issue title, and within hours, 4,000 developer machines had malware installed on them. The sentence wasn't code. It was a prompt injection, a natural language instruction that hijacked Cline's AI-powered triage bot and turned it into a supply chain weapon. That attack, now called Clinejection, is the first real-world proof that AI agents with CI/CD access can be weaponized through plain English. Today, that story, and then a very different kind of AI agent, one loading trucks in real warehouses with a world model trained on 100 million physical actions. Cline is one of the most popular open-source AI coding assistants, widely used by developers through VS Code and as a CLI tool published on NPM. Like a lot of modern open-source projects, Cline had set up an AI-powered issue triage system. When someone opened a GitHub issue, a workflow using Anthropic's Claude Code Action would automatically read the issue, classify it, and sometimes run commands to investigate, with access to tools like Bash, file reading, and file writing. Security researcher Adnan Khan discovered in late December 2025 that this setup had a critical flaw. The GitHub issue title was being interpolated directly into Claude's prompt without any sanitization. That means an attacker could embed instructions in the title itself, instructions that Claude would interpret and follow. Khan reported the vulnerability through a GitHub security advisory on January 1, 2026. He sent multiple follow-ups over the next 5 weeks. None received a response from the Cline team. So on February 9th, Khan went public. Cline patched within 30 minutes by removing the AI triage workflows entirely. They started rotating credentials the next day. But the rotation was botched. The team deleted the wrong token, leaving the actually compromised one still active. 8 days later, on February 17th, at 3:26 a.m. Pacific, an unknown actor, not Khan, used that still active NPM publish token to push Cline CLI version 2.3.0 to the NPM registry. The package included a post-install script that ran a single command, npm install-g openclaw at latest. Every developer who installed or updated to 2.3.0 got openclaw silently installed on their machine. The compromised package was live for roughly 8 hours before it was discovered and deprecated. In that window, approximately 4,000 downloads occurred. The full attack chain combined prompt injection, GitHub Actions cache poisoning, and credential exfiltration, 3 techniques stacked together, with a natural language sentence as the entry point. The payload in this case was relatively benign. OpenClaw is a legitimate open-source project. No credentials were stolen, no backdoors installed. This looks like a proof of concept, someone demonstrating the attack's feasibility. The same post-install hook could have delivered a credential stealer or a reverse shell. That's what makes this so significant. The attack surface here wasn't a code vulnerability in the traditional sense. It was a permissions problem with an AI agent. Cline's triage bot had write access to the CI/CD pipeline. It could execute bash commands, and its input, the GitHub issue title, was open to anyone on the internet. Chris Hughes, VP of Security Strategy at Zenity, put it directly, quote, "When a single issue title can influence an automated build pipeline and affect a published release, the risk is no longer theoretical. The industry needs to start recognizing AI agents as privileged actors that require governance. Every team running AI agents with CI/CD permissions should be auditing those permissions right now. The question isn't whether your AI agent is smart enough to catch a prompt injection. The question is what happens when it doesn't. If the answer is it can publish packages to NPM, or it can push to production, you have the same exposure Cline had. Cline has since released version 2.4.0, revoked the compromised token, and migrated their NPM publishing to use OpenID Connect through GitHub Actions, which eliminates stored tokens entirely. Watch for whether other major open-source projects running AI triage bots audit their own setups in response. The vulnerability pattern Khan identified, unsanitized issue titles fed into agent prompts with tool access, is not unique to Cline. Any project using similar AI workflows could have the same exposure. So that's what happens when an AI agent with real-world permissions goes wrong. But AI agents operating in the physical world are scaling fast too, and in that domain, the engineering challenge looks completely different. Instead of sandboxing permissions, you're predicting physics. A company called Dexterity just showed what that looks like at production scale. Dexterity, a robotics company founded in 2017 out of Stanford's robotics lab, announced Foresight on March 5th. Foresight is what they're calling a physics-consistent world model, a real-time representation of the physical environment that enables robots to perceive, reason, and act in warehouse operations. The headline application is autonomous truck loading, one of the most physically demanding and hardest-to-staff jobs in logistics. Dexterity's dual-armed robot called Mech uses Foresight to solve what is essentially a four-dimensional packing problem. 3 spatial dimensions plus time. For every package arriving on the line, the system determines where to place it on an evolving wall of freight inside the truck. The numbers on complexity are striking. Each box has up to 400 potential placements. Multiple walls are being packed simultaneously. The system has to optimize across density, stability, reachability, and dual-arm parallelism, meaning both robot arms need to work in coordination without colliding or blocking each other. Dexterity says this combinatorial problem is more complex than the game of Go. Foresight makes each placement decision in under 400 milliseconds. It predicts how placing one package will affect the structural integrity of the entire truckload. And it's trained on data from over 100 million autonomous actions performed in real production environments, not simulations, not lab settings. The system is already deployed. Dexterity says it's running across 6 production applications on 4 different robot types with 5 different hand configurations. Their CEO Samir Menon described it as, quote, real-time production-grade random box packing in 4D space-time. To expand the developer ecosystem, Dexterity is also launching the Foresight API Challenge this month, a competition where student teams build their own packing agents using the Foresight API and compete on a public leaderboard for up to $50,000 in prizes. Notably, no simulator is provided. Competitors have to build their own understanding of the underlying physics. Physical AI has had no shortage of impressive demos. Robots folding laundry, cooking eggs, doing backflips. The gap has always been between demos and deployment. Foresight is notable because it sits firmly on the deployment side of that gap. 100 million production actions is not a research milestone. It's an operational dataset. The architecture is also worth paying attention to. Dexterity built an agentic framework on top of Foresight, where separate perception, decision, and motion agents operate asynchronously. The system is described as interpretable and safety-first, giving operators visibility into why each placement decision was made. That matters for enterprise adoption. Warehouses and logistics companies need to trust and audit robotic systems, not just watch them work. The $50,000 student challenge is a strategic move too. By opening the API without providing a simulator, Dexterity is forcing participants to reason about physics from scratch, which is exactly the kind of talent pipeline a physical AI company needs. If successful, it creates an ecosystem of developers who already know how to build on Dexterity's stack. The immediate thing to watch is the Foresight API Challenge launching this month, and whether it attracts meaningful participation from the robotics research community. Longer term, Dexterity's claim that their stack is application agnostic and hardware agnostic is the bigger bet. If Foresight generalizes beyond truckloading to palletizing, sortation, and other warehouse tasks at the same production quality, that's a platform, not a product. The logistics industry moves slowly on adoption, but 100 million production actions is the kind of proof point that accelerates procurement decisions. An AI agent compromised a software supply chain through a GitHub issue title. Another AI agent is loading trucks across 6 warehouses using a world model trained on 100 million real-world actions. The range of what agents are doing right now, and what can go wrong, is expanding faster than most people realize. The question worth sitting with, are the guardrails keeping up? If you want to stay on top of this, we cover AI and tech news daily. Hit subscribe so you don't miss it. See you in the next one.